Okay, so this is just kind of a little summary just in case you're having trouble still drawing the force diagrams, okay? So the first thing you're going to do is draw your interaction diagram. So if you're still struggling with those, you need to go back to week 11 and watch that video and check that answer key and make sure you know that, okay? All right, once you have your interaction diagram, I suggest that you draw your FG arrow first that's down, because that's the force of gravity with the Earth, and that's always going to be there for every single object, and it's always going to point down. Okay, so that's an easy one to start with, okay? When you start to draw the rest of the forces, you need to know whether they're balanced or unbalanced. Okay, so you're looking for words like it's at rest, motionless, sitting still, or constant speed or constant velocity for balanced forces, okay? And then unbalanced would mean that there's a difference somehow between the left and the right or the up and the down, okay? Some kind of change, speeding up, slowing down, it'll say something like that, all right? Okay, so when you're drawing them, okay, so the force diagram at rest, let's just say, book on a table or something, right? Okay, so we'd have like force of gravity, book Earth, and force normal, book table or something, right? And notice how these are equal, okay? These are the same size, okay? The up equals the down, okay? There could be some kind of a situation, right, where maybe there's a down arrow and maybe there's two up arrows, okay? But still, that total amount would be the same if it's balanced, okay? Or it could be something kind of left and right. I'm gonna draw that a little different. Okay, oftentimes if it's something moving left and right on a surface, the up and down are gonna be equal, okay? And then side to side are also gonna be equal to each other, all right? And they may be bigger or smaller than the other ones. It really doesn't matter exactly, okay? So any of these positions would be at rest or constant velocity. You wouldn't really know if it's moving up, moving down, moving left, moving right. You don't know, or if it's at rest. All the force diagrams look the same, okay? Because force diagrams tell change in motion, okay? So it doesn't necessarily tell you which direction it's moving, okay? It just tells you how the change is happening, okay? If something is speeding up, we're going to try to always assume everything's going to the right in this class, okay? So it would be something, like a car, or, maybe there's like somebody pushing a box, or, I don't know, something, right? So in these cases, it'll probably be up and down will be balanced, okay? And then there may be only an arrow to the right, okay? Let's assume all these guys are moving to the right, okay? Or it could be something like there'd be an arrow to the right and like a smaller arrow to the left, all right? Or it could be like two arrows to the right, one arrow to the left, all right? But either way, the right side arrows would be winning, right? They would be more total than there are on the left side. Okay, that would make it speed up, all right? And it could also, like in the case of that ball, right, like if it's force of gravity and that's the only force acting on it, that means that the change in motion is going to be downward, right? So either slowing down on the way up or speeding up on the way down, okay? Slowing down, same thing. We're going to try to assume that everybody's going to the right, okay? And then, maybe this is something, maybe there is somebody pulling it or something, right? But the friction might be more than he's pulling it, okay? Or it could just be friction, right? And it's usually friction, not always, but it's usually friction that's making it slow down, okay? But either way, the left pull would outweigh the right pull. It would be bigger, okay? All right, and then, again, friction is a little bit tricky, okay? You'll get better at it as we go, okay? But oftentimes when something's slowing down, right, the friction would be to the right. And if something's speeding up, right, I could have, maybe like this guy is pushing the box and there is some friction still, like here on the surface, right, resisting it, but he's pushing harder than the friction. That would still make it speed up, okay? In the case when it's something that's like taking off from rest, like a car or a train or something, that friction could point to the right? Remember that traction of the wheels kind of grabbing, okay? So my best other advice is to draw friction last, okay? Because that'll help you see which way the friction's supposed to go, okay? All right, so that's kind of an overview, and then I'll do the other examples.